Hi everyone, my name is Joshua, and for our COS426 final project with Julia and Maya, we created Elyra. Elyra is an online multiplayer territory control game. Now I could explain how it works in words, but let me go ahead and just show you how it works. We implemented Google authentication so each user can have their own identity. Let me go ahead and log in as myself, and since this is my first time logging into the game, I need to choose a username, so let me go ahead and just choose Joshua1. Let's continue. And when you reach the game lobby, we have a very intuitive user interface that can quickly onboard users onto the game. First, you can click this How to Play button in the right upper corner to read about how to play the game, though we really recommend just diving in as the game is relatively simple. We also have a visual effects notice. This game does contain some bright colors and flashing laser effects, so players with severe epilepsy may be advised from playing. While the game is non-violent, we do have a degree of fighting and territory control with lasers, so it may not be suitable for all ages. To show you this game works, I'll go ahead and start solo practice. And we can see I spawn onto this 3D grid, and I'm represented by this little player here. I can spin around, I can shoot lasers, and I can also move around this grid. And you can start to see how this territory control works. As I move over the grid, or if I fire lasers, I capture more and more territory, as you can see in the upper right-hand corner. Now, what are all these things? I have walls on the map, and if I shoot at a wall, my beam gets absorbed. I have holes, which fire over, but I can't walk over them. And most importantly, we have mirrors. If you shoot at a mirror, your beam reflects off of it. We also have these things called generators, which will help us get more money. And the money can be used to purchase power-ups, such as this fast beam upgrade, which will make my beam really, really fast. Now, this game really wouldn't be so fun if it was only single player. So let's go ahead and create a multiplayer game so we can play with friends. I'll create a public multiplayer match, and we can see I'm waiting for players. My friend Maya is going to join in now, and we can go ahead and start the game. Now you can always wait for up to 4 players to even double the fun. Now we've created this game, and we can see our 2-minute timer now. In the upper right-hand corner, we can show the relative percentage that each user has. And at the end of the 2 minutes, the player with the most amount of territory wins the game. Now I want to note that me and Maya are on completely separate computers over the internet. So this can be done with friends all over the world. Now, as we move around the map, we can go ahead and capture territory back and forth. We can fight for control over the generators. We can make our upgrades, such as multi, like this. And ultimately, just keep fighting and try to win the game. Now, let me talk a little bit about implementation details. On the server, we use a programming language called Elixir with the Phoenix framework, which allows us to build APIs. Now, the reason we use the Elixir programming language is that it's really good at handling real-time applications, in this case, a real-time game. We control the data flow with things called WebSockets, which establish a bidirectional communication between server and client. This allows us to have game state sync, and we send game state syncs at a 20 hertz frequency. Now, it would be really naive to just send over the entire game. That would be really slow, and it would be a lot of data transfer. And so what we do is we do delta sync. So each player, when they make a movement or do an action, we just send that change over to the server. The server validates to make sure the player isn't cheating and sending random inputs to it, and then it syncs to all players. Now, there's a lot of front-end logic going on here. This is a computer graphics course, after all. We use Three.js in order to have 3D graphics, but since there's a lot of internal game state, we use something called Svelte, which is a framework for reactive front-end programming. We use a wrapper library called Th3RLT, which makes Three.js development in Svelte have a lot better developer experience. Now, a lot of the implementation details come from our physics, especially the beam physics. Now, I noted earlier, and the game is going to end real fast, so let me show you. Beams fire over holes, they get absorbed by walls, and they get reflected by mirrors. How do we do this? Well, it's a very simple beam calculation in order to calculate which tiles the beam passes over. We use a simple DDA raycasting algorithm. For the others, with the wall and mirror collisions, it's a bit more complicated. This is because we're not fully continuous. We're only sending at a 20 hertz tick rate. And so what we need to do is calculate the first tick in which a beam has crossed through a wall or mirror, and then handle relative physics calculations from there. Now, there's a lot more we could talk about, but you can always explore the game for yourself at elyra.tigerapps.org or see our GitHub open source code to dive more into details. We hope to see you on the game soon, and thank you for listening.